everyone to my channel. In this video we're going to see how to solve the equation using a matrix method, which is actually an important 5 marker, and from the chapter determinants, chapter 4, exercise 4.6. we're going to solve from problem 7 to 14. Okay, so first problem is 7th one, which is 5x plus 2y is equal to 4, 7x plus 3y is equal to 5. The very important formula we are going to remember is, for this, ax is equal to b, so x is equal to a inverse b. Okay, we have to find first a inverse. We have to note down a, b and x. Okay, and then after substituting we'll get the value of x and y. So first, what is a? A is 5 coefficient of x in one column, coefficient of y in one column. If there's another variable called z, the variable's coefficient in another column. Okay, in such a way we have to write a. So 5, 7, 2 and 3. This is a. And what is b? B is the constants. Okay, so constant, which is 4 and 5, and x. X is the variables that we are supposed to find, x and y. How do we find a inverse? We know a inverse is 1 by determinant of a into adjoint a. For 2 cross 2 matrix, adjoint of a, finding of adjoint of a is very much easy. That just swap the diagonals, change the sign of the anti-diagonals. If it is plus, change it to minus. If it is minus, change it to plus. That is simply multiply the anti-diagonals by negative sign and swap the diagonals. Okay, so what I have told is, we have to swap the diagonals 3 and 5 and change the sign of the anti-diagonals. The actual method is, first element we have to note down minor and then a cofactor. After finding cofactor, we have to form a cofactor matrix. After that cofactor matrix, we have to write adjoint of a. Adjoint of a is nothing but the inverse of transpose of cofactor matrix. Okay, so elements are 5, 2, 7, 3. 5, 2, 7, 3. For 5, minor is delete the row and column. 3 is the minor. For 2, delete the row and column. 7. For 7, 2, and for 3, it's 5. In 2 cross 2 matrix, the sign is plus, minus, minus, plus. Okay, just with sign we are going to write in the cofactor matrix. Okay, hope so it is visible. Yeah, plus 3, minus 7, minus 2 and 5. Now we are going to write cofactor matrix. Cofactor matrix is 3, minus 7, minus 2 and 5. Now adjoint of a. Adjoint of a is the inverse. Adjoint of a is the transpose of cofactor, which is 3, minus 2, minus 7, 5. The same we have got. So the shortcut method is swap the diagonals, change the sign of the anti-diagonals, for only for 2 cross 2, not for 3 cross 3. Okay, 3 cross 3 we have to find cofactor. From cofactor we have to find an adjoint, and then only we can write the a inverse. Okay, now we have to find the determinant of a. Determinant of a is the diagonal. 5 into 3 minus the anti-diagonal. 7 into 2. 5 3 is 15, minus 7 4s are 7 2s are 14, which is equal to 1. So we have found everything. Now x is equal to a inverse of b. We know x is x and y, and a inverse is 1 by 1, which is determinant, and adjoint of a is 3, minus 2, minus 7, minus 5. B is 4 and 5. We know how to do product. So first the row and the first column. First row, first column, first row, first column. And always in this matrix method, the product will end up in like only one column will be left out. Okay, so it can be 2 cross 1 or 3 cross 1. If it is 2 variables, the final order of the matrix after multiplication is 2 cross 1. And if it is 3 variables x, y, z, it is 3 cross 1. Okay, yeah. So 1 by 1 is 1. So we are not going to write it. 3 into 4 plus minus 2 into 5, then minus 7 into 4 plus minus 5 into 5. Okay, 3 4s 12. 9 plus into minus is minus. 5 2s are 10. 28, and plus into minus is minus. 5 5s 25, which is equal to, and 12 minus 10 is 2. 28, which is minus 28. This is plus. 25 is minus 3. Okay, this is actually plus, right? Yeah, plus 5. Sorry, this is plus 5. So plus 5. It is plus 25, which is minus 3. So therefore, finally, we have to write x is 2, y is minus 3. Eighth question is 2x minus y is equal to minus 2. 3x plus 4y is equal to 3. So A is 2, 3, minus 1 and 4. B is minus 2 and 3. And x is x, y. There are only two variables. Adjoint of A, for only for 2 cross 2, we can write directly. Swap the diagonals, change the sign of the anti-diagonals. Okay. So, which is 4 plus 1 minus 3 and 2. This is the adjoint of A. And then the determinant. 4 2s are 2, 4s are 8, minus 3 1s are minus 3. Minus into minus is plus 3. Determinant A is equal to 11. Okay, plus 11. Now, x is equal to A inverse B. X is xy. 1 by 11. Adjoint of A is, okay, so A inverse is 1 by determinant A into adjoint of A. Adjoint of A is 4, minus 3, 1 and 2. B is minus 2 and 3. 1 by 11. 4 into minus 2 plus 1 into 3. Okay, and then minus 3 into minus 2 plus 3 into 2. 1 by 11. 4 2's minus 8 plus 3 plus 6 plus 6. 1 by 11 minus 5. Okay, minus 5 and then 6 is 12. Now x is equal to minus 5 by 11 and y is equal to 12 by 11 is the answer. 3x minus 5y is 7 and 4x minus 3y is equal to 3, which is ninth problem. So A is equal to 4, 3 minus 3 minus 5. So B is 3 and 7. Z is only two variables, x and y. Okay. Adjoint of A is minus 5, 4 and this 3 is plus 3 and this is minus 3. Okay. And then the determinant is 4, 5 minus of minus 3 into 3. Okay, 4 5s are 20 plus minus 20 plus 9, which is minus 11. Now the A inverse is 1 by determinant A adjoint A, which is minus 1 by 11. Adjoint A is minus 5 minus 3, 3 and 4. Okay, now x is equal to A inverse B. X is xy. A inverse is minus 1 by 11, minus 5, minus 3, 3, 4. B is 3 and 7. And now, so x, y is equal to minus 1 by 11, minus 5 into 3, plus 3 into 7. And minus 3 into 3 plus 4 into 7. Minus 15 plus 21 minus 9 plus 28, which is equal to minus 1 by 11, which is plus 6 and plus 19. Okay, so therefore x is equal to minus 6 by 11 and y is equal to minus 19 by 11. Okay. 10th question is 5x plus 2y is equal to 3. 3x plus 2y is equal to 5. Now, A is 5, 3, 2, 2. B is 3, 5. X is x and y. Okay. Now, adjoint of A is 2, 5, minus 2, minus 3. Determinant of A, 5 to 2 minus 3 into 2. 5 2s are 10, 3 2s are 6, which is plus 4. A inverse is 1 by determinant of A and adjoint of A into adjoint of A. 1 by determinant of A is 1 by 4. Adjoint A is 2 minus 2 minus 3 and 5. Okay, now x is equal to A inverse B. X is x, y, A inverse is 1 by 4, 2 minus 3 minus 2, 5. B is 3, 5. Now 1 by 4, 3, 2 into 3 plus minus 2 into 5. Minus 3 into 3 plus 5 into 5. 1 by 4, 3 2s are 6, 5 2s are 10, minus 10. 3 3s are 9 plus 25, which is equal to 1 by 4. 6 minus 10 is minus 4. Minus 10 plus 25 is 16. So we get minus 1 on multiplying inside, and 16 by 4 is 4. Okay. Therefore, x is equal to minus 1 and y is equal to 4. The 11th question is 2x plus y plus z is equal to 1. X minus 2y minus z is equal to 3 by 2. 3y minus 5z is equal to 9. So here it is given as only y and z, but where's x in the third equation? So x is 0x plus 3y minus 5z is equal to 9. Here we are going to solve three variables. So we are going to form 3 cross 3 matrix here. So first, what is A? A is equal to 2, 1, 0. 1 minus 2 plus 3. 1 minus 1 minus 5. Now B is equal to 1, 3 by 2 and then is 9. And in this, I am going to teach about 3 ways of finding the cofactor, and which you feel easy that you can continue for the next problems. Okay. I have written the A matrix here. 2, 1, 1, 1 minus 2 minus 1, 0, 3 minus 5. Okay. The first is we have to note down the element, minor and a cofactor. Okay. Elements are 2, 1, 1, 1 minus 2 minus 1, 0, 3 minus 5. These are the elements. Okay, so minor. Delete the row and column. So 5 into 2. 5 2s are plus 10. Minus of 3 1s are 3 plus 3, which is 13. Okay, this is plus. Okay, the sign is plus minus plus minus plus minus plus minus plus. Okay, this is a sign for 3 cross 3 matrix. Yeah, first one is 13. For the 1, okay, so delete the row and column. Remaining is minus 5 minus of 0, which is minus 5. Minus into minus is plus 5. And for this, delete the row and column. 3 1s are 3 minus 0, which is 3. Okay, and the next one, 1. For this one, we have to delete the row and the column, which is minus 5, and 5 into 1 is minus 5, minus of 3 into 1 is 3, minus 8. Okay, which is minus 8, minus into minus is plus 8. Okay, and then for this 2, minus 2, delete the row and column. 2 into 5 minus 10 minus 0, which is minus 10. Plus into minus is minus. And for this minus 1, delete the row and column. 3 2s are 6, minus 0, minus into plus is minus 6. For this 0, delete the row and column. 1 into 1 is minus 1, and 2 into 1 is plus 2, which is minus 1. Minus into plus is minus. And for this, delete the row and column. 2 into minus 1 is minus 2 plus minus 2 minus the third one we have deleted. 2 into minus 1 is minus 2. Minus of 1 into 1 is 1, which is minus 3. Minus into minus is plus 3. And then for this, delete the row and column. 2 into 2 is minus 4. Minus of 1 into 1 is 1. Okay, minus 4 minus 1 is minus 5. We have found the cofactor. So cofactor is equal to 13, 5, 3, 8, minus 10, minus 6, 1, 3 minus 5. And this is one way of finding the cofactor. The second way is write a long brackets like this. So first write the sign plus minus plus minus plus minus. Okay, so yeah, plus minus plus written. Then we have to take mod like this for each of the sign. Okay, then for 2, delete this row and this column. The remaining elements we have to write minus 2, minus 1, 3, minus 5. For this one, if we delete, we'll get 1, minus 1, 0, minus 5. And for last one, which is 1, minus 2, 0, and 3. And for this, it is 1, 1, 3, minus 5. Okay, this is 2, 1, 0, minus 5. For the last one, 2, 1, 0, 3. And the next one is 1, 1, minus 2, minus 1, 2, 1, 1, minus 1, 2, 1, 1, minus 2. Okay, we have got. Now we can write the cofactor directly. Cofactor is equal to 5 2s are plus 10 plus of 5 2s are plus 10, 3 1s are 3 minus of minus 3, which is plus 3, which is 13. The same we have got. Then minus of 5 minus 5 and minus 0 plus 5 plus of 3 minus 0. Okay, and then is minus of minus 5 minus 3 plus minus 10 minus 0 minus 6 minus 0 plus minus 1 plus 2 minus 2 minus 1 plus minus 4 minus 1. Okay, so 10 minus of minus is plus 3, 10 plus 3 is 13, plus 13 minus 5 minus 5 into minus is plus 5. Next, plus 3. Then minus 5 minus 3 is minus 8, minus into minus is plus 8. Minus 10 into plus is minus 10. Minus 6 is minus 6. Minus 1 plus 2 is 1 plus 1. Then minus 2 minus 3 is minus 3. Minus 3 into minus is 3. Next, minus 4 minus 5 minus 1 is minus 5. So the same cofactor. This is the first method. This is the second method. And the third method is, so we have 2, 1, 0, 1, 1, minus 2, minus 1, 3, minus 5 as A matrix, right? Now, this is 3 cross 3 matrix. We have to make it 5 cross 5 matrix. Okay. So, repeat the first row and the second row elements and decide the first column and the second column elements. Okay, this is 5 cross 5 matrix now. Now, delete this row. Delete the first row and the first column. First row and first column we have deleted. Now, to 5 2s are plus 10. And then 3 into minus 1 is minus of 3 into minus 1 is minus 3. Okay, plus 3, which is 13. Now, minus 1 into 5. Now, the diagonal minus anti-diagonal. So, diagonal is 5 2s are plus 10. Minus 3 into 3 is 3 into 1 is minus 3. Minus 3 into minus is plus 3, which is 13. Okay, so see. Then minus 1 into 0 is minus which is 0 and minus 5. Minus 5 into minus is plus 5. Okay, then 1 into 3 is 3 and 0 is 0. Okay, 3 1s are 3, 5 1s are 5, plus 5 we get, minus into minus is plus, 5 plus 3 is 8 and 5 2s are 10, minus 10 which is minus 10, 0, and then this is 0, minus 6, and 1 into minus 1 is minus 1, 3 into 1 is minus 2 into 1 is plus 2, and this is 1. 1 1s are 1, 2. 2 into minus 1 is plus 2. Minus 1 into minus, which is 1 into 1 minus of 2 into minus 1 is 2, which is 1 plus 2, which is 3. Okay, 2 2s are minus 4, minus of 1 1s are 1, which is minus 5. The same we have got. Okay, so these are the three methods of finding cofactors. We have found the cofactor. Now we have to find the adjoint of A. Adjoint of A is nothing but the transpose of the cofactor. 13 5 3 8 minus 10 minus 6 1 3 minus 5. Now determinant of A. So if we have found the cofactor and A matrix, it is very easy to find the determinant of A. Just what you do is take at least one row or one column, any one row, multiply with the corresponding row of that matrix and add up the terms, you will get the determinant of A. So 13 into 2 plus 5 into 1 plus 3 into 1. This is the determinant of A. Determinant of A is 26 plus 5 plus 3. 5 plus 3 is 9, 14. 34 is the determinant of this matrix. Okay, so we have found the determinant of this matrix, which is 34. Now x is equal to A inverse B. X is x, y, z. Okay, and what is our A transpose? A inverse it is. Okay, A inverse is 1 by 34. Adjoint of A, 1 by determinant A, adjoint A into B. Then, which is x, y, z is equal to 1 by 34, 13, 5, 3, 8, minus 10, minus 6, 1, 3, minus 5. And B is 1, 3 by 2 and 9. Okay, x, y, z is equal to 1 by 34. We have to multiply both of them. So 13 ones are 13 plus 3 2 4s are 4 3s are 12 plus 9 5 ones are 5 2 5s are 3 5s are minus 15 plus 3 9s are 27 3 ones are 3 2 3s are and 3 3s are minus 9 minus 45. So x, y, z is equal to 1 by 34, 13 plus 12 plus 9 is 34, and this is 17, and 3 minus, this is actually 9. Okay, 9 minus 45 is minus 51. Okay, so always in 3 cross 3 matrix, the product of adjoint A and B we get as the multiple of the determinant. Okay, either the multiple of the determinant or the determinant is divisible by that element. Okay, so now if we write, it is actually x, y, z is equal to 34 by 34 is 1. 17 by 34 is 1 by 2, and minus 51 by 34 is 3 by 2. Okay, now x is equal to 1, y is equal to 1 by 2, and z is equal to minus 3 by 2. The 12th problem is given as x minus y plus z is equal to 4, to x plus y minus 3z is equal to 0, and x plus y plus z is equal to 2. So A is 1 2 1 minus 1 1 1 minus 3 1. B is 4 0 2. X is x, y, z. If we have to find a cofactor is equal to, we have to write 1 2 1 minus 1 1 1 minus 3 1 and 1 1 minus 1 1 2 1 minus 3 1 2 1 1 2 minus 1 1 1 minus 1 1. Delete the row and column. 1 ones are 1 plus 3 is 4, and minus 3 minus 2 is minus 5. 2 ones are 2 minus 1 is 1. 1 ones are 1 plus 1 is 2. 1 minus 1 is 0. And then minus 1 minus 1 is minus 2. And this is 3 minus 1 is 2. Then 2, 3 ones are 3 plus 5, 5, and this is 1 ones are 1 plus 2 is 3. And if you have any doubt with the cofactor, so you have to multiply each of the row with the corresponding row of the matrix to find the determinant, right? So multiply each of the row with the row. So determinant will get as 4 into 1 minus 5 into minus 1 plus, plus of minus 5 plus 1 into 1. Okay, 4 plus 5 plus 1 is 10. So for the first row we have got 10, and for the second row if we check 2 2s are 4 plus 3 2s are plus 6, we are getting 10. So the second row is also correct. Third row 2 plus 5 plus 3 is actually 10. So therefore our cofactor is correct. Okay, and then determinant we found as 10. Now adjoint of A, adjoint is of that cofactor, which is 4 minus 1 1 2 0 minus 2 2 5 3. Okay, now x is equal to A inverse B, x, y, z. A inverse is 1 by determinant is 10, and then 4, 2, 2, minus 5, 0, 5, 1, minus 2, 3. And then B is 4, 0, 2. Okay, now 1 by 10. Multiply 4 4s are 16, 2 zeros are 0, 2 2s are 4. Minus 4 5s are 20, 0 into 0, plus 5 2s are 10. 4 plus 3 2s are 6. So we get 1 by 10, 20, minus 10 and 10. So therefore x is equal to 10, 20 by 10 is 2, y is equal to minus 10 by 10 is minus 1, z is equal to 1. This is our answer. X is equal to 2, y is equal to minus 1, z is equal to 1. 13th one is given as to x plus 3y plus 3z is equal to 5, x minus 2y plus z is equal to minus 4, 3x minus y minus 2z is equal to 3. So first A is equal to 2, 1, 3, 3 minus 2 minus 1, 3, 1 minus 2. And B is 5 minus 4, 3. And x is x, y, z. There are 3 variables we are supposed to find. So cofactor first we have to find. To find cofactor, 2, 1, 3, 3, 3, minus 2, minus 1, 1, minus 2. 2, 3, 3, 1 minus 2, 1, 2, 1, 3, 2, 1, 3 minus 2, minus 1, 3 minus 2. Delete the row and a column. Delete the row and a column. Okay. 2 2s are 4. 4 plus 1 is 5. 3 plus 2 is 5. 3 plus 2. Minus 1 plus 6 is minus 1 plus 6 is 5. Next, minus 3 plus 6 is minus 3 plus 6 is 3. 2 2s are 4 minus 9. 4 minus 9 is minus 13. 3 3s are 9 plus 2 is 11. 9 plus 2 is 11. 3 plus 6. 3 plus 6 is 9. 3 ones are 3. Minus 2 is 1. Minus 4. Minus 3 is minus 7. Minus 4 minus 3 is minus 7. Multiply the corresponding terms and add up that. So at determinant we get as 5 into 2 plus 5 into 3 plus 5 into 3. 5 2 is 10. 5 3 is 15 plus 5 3 is 15. 10 plus 30, which is equal to 40. Determinant is 40. If you have any doubt with your cofactor, multiply, check for each of the rows. So if you get the determinant the same, so your cofactor is correct. Now adjoint of A. Adjoint of A is the transpose of the cofactor. 5 5 5, 3 minus 13, 11, 9 1 minus 7. Now x is equal to A inverse B. X, y, z is equal to A inverse is 1 by determinant, which is 1 by 40, and adjoint is 5 5 5, 3 minus 13, 11, 9 1 minus 7. It is very important to write the A inverse formula, which is 1 by determinant into adjoint A. If you write this only, you will get marks, or else marks will not be awarded. Then B is 5 minus 4 and 3, which is equal to 1 by 40. 5 5s 25 minus 3 4s 12 plus 27. 5 5s 25 plus 13 4s 52 plus 3. 5 5s 25 minus 44 minus 21, which is equal to 1 by 40. 25 minus 12 plus 27 is 40. 25 plus 52 plus 3 is 80. 25 minus 44 minus 21 is minus 40. Now x is equal to 40 by 40 is 1. Y is equal to x, y, z. Okay, so x is equal to 40 by 40 is 1. Y is equal to 80 by 40 is 2. And z is equal to minus 1. The last problem is x minus y plus 2z is equal to 7. 3x plus 4y minus 5z is equal to minus 5. 2x minus y plus 3z is equal to 12. So A is 1, 3, 2, minus 1, 4, minus 1, 2, minus 5, 3. And B is 5 minus, 7 minus 5 and 12. Okay. And x is x, y and z. Okay. Now cofactor. To find cofactor, we have to write 5 cross 5 matrix. 1 minus 1, 2, 3, 4 minus 5, 2 minus 1, 3, 1 minus 1, 2, 3, 4 minus 5, 1, 3, 2, 1, 3, minus 1, 4, minus 1, minus 1, 4. Okay. Now delete the row and the column. 4 3s are 12 plus 5 1s are 5. 12 plus 5, 4 3s are 12 minus 4 3s are 12 minus 5 is 7. 5 2s are 10 minus 10 minus 9 is minus 19. Minus 3 minus 8 is minus 11. Minus 2 plus 3 is 1. 3 minus 4 minus 1. Minus 2 plus 1 is minus 2 plus 1 is minus 1. 5 minus 8. 5 minus 8 is minus 3. 3 2s are 6. Plus 5. 6 plus 5 is 11. 4. 1 4s are 4. Minus 3 plus 3. 4 plus 3 is 7. Okay, this is the cofactor. Now adjoint of A. Adjoint of A is 7 minus 19 minus 11. 1 minus 1 minus 1 minus 3 11 7. And then determinant of A. 7 into 1 minus 19 into minus 1 minus 11. It is actually plus. Okay, so plus of minus 11 into 2. 7 plus 19 plus 22. Okay, this is minus 22. 7 plus 19 minus 22, which is equal to 4. Now x is equal to A inverse B. X, y, z is equal to A inverse is 1 by determinant A and adjoint A into adjoint A into B, which is equal to x, y, z is equal to 1 by determinant is 4. Adjoint is 7 minus 19 minus 11. 1 minus 1 minus 1 minus 3 11 7. B is 7 minus 5 and 12. Now 1 by 4. 7 7s are 49 minus 5 minus 36. Then minus 19 into 7 is minus 133 plus 5 plus 132. Then minus 11 into 7 is minus 77 plus 5. 7 12s are 84. Then x, y, z. X, y, z is equal to 1 by 4. 49 minus 5 minus 36 is 8, minus 133 plus 5 plus 132 is 4, 77, 5, 84 is 12. We get x, y, z is equal to 4 2s are 8, 4 1s are 4 3s are. So it is x is equal to 2, y is equal to 1, and z is equal to 3. Therefore, we have found x, y.